Hey guys, this video is going to be for notes on energy. Right now it's labeled as number 120. So, mechanical energy, that's the main type of energy we're going to be talking about. What is mechanical energy? Well, energy is the ability to do work. That's why we learned about work and power first. So, when you're doing work, when you're pushing something for a distance using a force, you're using energy. Energy is also measured in joules, just like work. So work and energy use the same exact units. If you recall, power does not have the same units. Power uses watts. So work and energy both use joules. Doesn't matter what type of energy, we're going to learn a couple different types. All different types use joules for their units. So capital J. Now, there are two main categories of energy. There's mechanical and non-mechanical. We are only going to deal with mechanical energy. So, what is mechanical energy? It is kinetic energy, which is the energy of something that moves, and potential energy, the energy due to something having a position. So this is like the potential to do something. For example, gravitational is the potential for something to fall. If I hold up this pencil has gravitational potential energy, so it has the ability to fall when I let it go. Kinetic energy is not the ability to do something. It's just the energy of motion. If you're moving, you have kinetic energy. There's also elastic energy. This is the energy that's stored within a spring or something that's stretchy, like a rubber band or something like that. So spring energy is called elastic. Energy due to a height is called gravitational. Energy if you're moving is called kinetic. We use Ke for kinetic energy, capital Ke. So in an equation, you'll see Ke. For total energy, or the entire energy combined for a system, we use Me, because it's mechanical, Me. And potential, we use Pe, capital P, capital E. Now, we're mostly, if not entirely, going to deal with gravitational for potential energy. So you don't have to worry about the difference between gravitational and elastic. It's just going to be potential for us. But I will ask you some situations of a spring and saying, what kind of energy does it have? You have to know that a spring or something that's stretchy has potential energy. So we have potential and kinetic. These are the non-mechanical energies. We will not be dealing with them this year, but they're good to know about. All right, so let's go through some situations. This is where some of the concepts come from. There are some concepts from work and power. This is the rest of them. So I would give you a situation and say what type of energy is present. So a dog is running on the ground. You're going to ask yourself 3 questions here to figure out the answer to this. Question 1, is it moving? By it, I mean whatever the object is in this situation. In this case, a dog. Is the dog moving? Yes. If you say yes, then it has kinetic energy. Does the dog have a height? This dog's on the ground, so no, it doesn't have a height, so it doesn't have any gravitational potential energy. Is there a spring in this problem? No, there's no spring. So that's your third question. Is there a spring? So if there was a spring, you'd say there's a gravitational elastic energy. If there's a height, you'd say gravitational potential. Did I say gravitational elastic? Yeah, I did. Elastic potential energy is the spring. Gravitational potential is the height, and kinetic is the moving. So again, moving, height, spring. Those are your 3 questions. The only one we said yes to in this one was the moving. So, Ke. Next one, airplane flying high above the ground. So, take a moment to yourself, try and think of what type of energy this is. Okay, I'm assuming you paused it long enough to answer it for yourself. This one both has a height and is moving. There is not a spring. So those are our 3 questions. We said yes to height and moving, so it has kinetic and potential. Which type of potential? It's gravitational, because it has a height. Book held 4 meters above a desktop. Pause the video, answer it for yourself. Okay, not moving, does have a height, does not have a spring. We only said yes to one, so it has potential energy due to gravity, or gravitational. Last one, loaded dart gun with a compressed spring mechanism. Pause the video, answer it for yourself. Okay, assuming you paused it. No to moving, no to height, yes to the spring. So we only said yes to one of them, potential energy, and it's elastic or spring potential. Now, if this dart gun was moving, say you're running after someone with it, then it also has KE, so you'd have two of them. If it was moving and you're running after it holding it, because now it's off the ground, you have the potential to drop it, you'd have all three. So you'd have two potentials and a kinetic. And then you have to say one's potential gravity, one's potential elastic or spring. I don't care if you say elastic or spring. All right, energy motion is called kinetic energy. This is the formula for it. So kinetic energy is equal to 1/2 times the mass times the speed squared. Only the speed is squared here, so only the v. So if we have an object that's 20 kilograms, it's moving at 5 meters per second. How much kinetic energy does it have? You would do 1/2 times the 20, that's 10, times 5 squared. 5 squared is 25. 25 times 10 is 250 joules. So again, 1/2 times the mass times the speed squared. So 1/2 times 20 times 5 squared. Stored energy is called potential. This guy has both gravitational potential, and when he falls, he'll have kinetic and elastic because of the rope. So we're only going to deal with gravitational. Gravitational is PE equals mass times gravity times height. And by gravity, I mean 9.8. So the mass times 9.8 times the height. If we went to a different planet, this G would change to whatever G you'd have on that planet. But we always deal with Earth, at least for the most part. So mg is the weight. Whoa, h is the height. That's not a coincidence. If you pick something up, remember the work done to pick it up and raise it some height is the weight times the height. Hey, that work gives you the potential energy. It has the potential to fall after that, right? All right, potential energy. 25 kilogram mass is held 10 meters above the ground. What's its potential energy? So again, you're using P equals mgh. M is 25. G is 9.8. H is 10. So 25 times 9.8 times 10 gives us 2450 joules. All right. What is energy? Energy is the ability to work. So what's an example of some work? Work is moving something, so lifting something up or pushing something. That energy has to come from somewhere. Most of the energy in the universe comes from stars nowadays. Whatever energy there wasn't already in the universe, we get from stars. So our solar system, all our energy comes from our sun. Energy cannot be created or destroyed. It has to go from something into something else. You can't just make energy out of nowhere. It can transform into other forms of energy, but it can't just be created out of nowhere. It has to go from one type of energy to another. So you get energy from plants and animals. You use that energy to do work. So moving, running, whatever. That energy the plants and animals got it from plants got it from the sun, for the most part. So all that energy had to come from somewhere. So 20 kilogram snowboarder at rest is at a height of 15 meters. What is their potential energy? So are they moving? No, they're at rest. Do they have a height? Yes. Do they have a spring? No. So the only energy they have is gravitational potential. So to find their total energy right now, you just find their potential energy, which is 20 times 9.8 times 15. So PE equals mgh. 20 times 9.8 times 15 gives us 2940 joules. So that's their total energy at the start. Can this ever be destroyed? No, but it can be turned into other types of energy. So when they go down a hill, because they're at a height of 15 meters, as they go down, that potential energy slowly turns into kinetic energy. So it doesn't just disappear. At exactly halfway between the 15 meters and the ground, they'll have equal amounts of potential and kinetic. When they get to the ground, all of that potential they started with, 2940, becomes kinetic by the end. So it all turns into motion. All right, what is their kinetic energy? So if they're at rest, are they moving? No, so they have 0 energy, but not 0. OJ, orange juice, or OJ Simpson. Let's move this so that you can see. So 0 joules of kinetic energy at the top. What's their total energy? So all you're doing is adding these together to get their total. The potential at the start plus the kinetic at the start gives you their total, 2940. That total will never change. So from the start to the end, the total does not change. Unless there's work done, we may or may not get into that this year. So assume you're still dealing with the same snowboarder and that you're now 10 meters above the ground. So they've gone down a little bit. They're only 10 meters. Do they have a height? Yes. Are they moving? Yeah, they're going to be moving at this point. They've gone down the hill a little bit. There's no spring still. So now you have 2 energies. First thing we have to figure out is what's the potential energy at the new height. So they have the same exact mass, 20 kilograms times 9.8 times 10 gives you their potential energy at that spot. Their total energy is not going to change from the start. You've already answered that question. So 2940. What's their kinetic energy at that spot? Take the total, subtract the potential that they now have. That's going to be their kinetic energy at that new spot. And then using that kinetic energy, Ke equals 1/2 mv squared, you can solve for their speed, solve for v. So the kinetic energy you have left equals 1/2 times their mass. What was their mass? 20 times v squared, solve for v. I would stop the video at this point and give it a shot, try it yourself. I just walked you through how to do it, so make sure you can do it. And these are the answers. Notice the total energy is exactly what I said, 2940. 2940 minus 1960 gives you 980. 980 equals half times 20 times v squared. When you solve for v, you're going to get 9.9. If you could not do these calculations, make sure to ask me about it in class so we can go over how to do it. So when they reach the ground, now find these 3: potential, total, kinetic, speed. First one I would do, honestly, is that total energy, because you know it can't change no matter where you are in the problem. So 2940, done. Potential energy, they're on the ground. They have no height anymore, 0. So total energy minus potential gives you the kinetic. That's 2940. 2940 minus 0 gives you 2940. So now for the speed, you're going to do 2940 equals 1/2 times the mass times the speed squared. So mass is 20. And the speed is what you're looking for. So it's going to be 2940 equals 1/2 times 20 times v squared. Solve for v. So you're going to take half of 20, do 2940 divided by that, and then you square root your answer. And these are your answers. Hopefully you tried it yourself before checking. And that's it for today.